Hello everyone, and welcome to this third installment of the series of tutorials from ChETEC-INFRA. Today we're going to be looking at a post-processing code called NuPPN, which is developed and maintained by the NuGrid collaboration. In order to gain access to this, you'll have to come to this web page, the NuGrid home page, go to the members area, and then contact either Marco Pignatari or Alexander Hall-Smith, who will be able to add you to the group. Once that's been done and you have access to either the GitHub or the GitLab, then you'll go to whichever you prefer. I prefer GitHub. Go down to the file repository here and type in NuPPN, which is the name of the repository, which contains all of the different post-processing codes. So we're going to go into NuPPN, and here you can see we have frames. That's where the different codes are. But I want you to go to this drop down menu, the branch drop down menu, and then scroll down until we find modular 2. This is the version of the code that we'll be installing. Now the master branch is fine, but there are a few extras that are part of modular 2 that haven't been added to the master branch yet, and that's why we're using that. Once you've done that, let's go over to a terminal and we're going to SCP from our downloads folder the NuPPN modular2.zip file to our workstation on Viper. Now I won't press enter as I already have a copy on Viper, but all you'll have to do is do that and then put in your password, and that will copy the file over. That might take a little time too, but once it's done, come back to this video and we'll show you how to install NuPPN. Hello, welcome back. This is my home directory on Viper, and you can see I have the relevant zip folder here, which we're going to unzip now. Takes a few seconds. I'll probably cut this out. There we have it. It's unzipped and in a folder which is called NuPPN modular 2. So I'll move into there. In here you can see there's a number of different directories. We won't bother with physics, solver, test, any of those just now. Firstly, we're going to move into frames. And in frames, we can see there are 3 new directories and a README. The 3 directories correspond to the 3 different post-processing codes that are available to you: PPN, TPPNP, and NuPPN. But of course, this tutorial is focused on NuPPN, so let's move into that directory and then have another look. So in here we have documentation, a run template, source, and this folder here, USEEPP. We're going to move into source. And you'll see that there's another folder called Make.local. We're going to have to go into there. And in here we have a load of make files that we use to compile the NuPPN code. We're going to choose one to copy up one directory. Doesn't really matter which, as we'll be changing quite a lot of them, the contents of it. So let's just copy bashrc. Why not? Copy this up. We'll move back up one directory, and then we're going to move that new Make.local bashrc to a file called Make.local. There we have it. There are a number of different parameters that have to be set in the Make.local. First of all, let's change the name of this to Viper, which is the name of the machine that we're on. The architecture, let me show you. The architectures are shown in Arch. And these are the different options that you have. For Viper, we're going to be using the x86 64G Fortran. So let's copy that, move back up, Make.local, And let's delete that and add this in its place. And then NuPPNP needs to know where it sits on your machine. So we can do that quite simply by taking the present working directory up to modular 2 here. We'll copy that. And then we can add that in. Make sure there's no spaces at the end there, but the slash is fine either way. And as it says here, you don't need to change any of this. Those are fine, they're just relative to this ppn home that you've just set. And this will be wherever your ppn is installed. And then finally, quite importantly, is the SE home. Now, you can install your own version of SE, although it is quite tricky and it will take some time. Thankfully, there is a version that is installed and available in a shared directory, which I'll detail down in the description below. But just so you know, we are looking for this directory, home gs NuGrid libraries se lib. So that's where the se libraries live. Now, this particular make local, which I've selected, is in fact not quite right for the use that we have. Now, the setup for this make file that I chose randomly is actually not quite right for the newest version of NuPPNP. And in fact, it's missing a very important piece of information, and that's the location of MPI on this machine. So we can get rid of these and we will add MPI home, and then there we go. So this is the location of MPI on Viper, and again we'll add that in the description below. And then there are also two other considerations that we need to make, and that's the fact that we want to use the Superlu solvers, the Superlu libraries, which are given with these paths here, which will also be available in the description. And this just means that the code solves much faster than it would do if it was using the linear algebra options in the code that are native to the code. So once all those things have been set, the architecture, ppn home, SE home, MPI home, and then using the Superlu, which is available on Viper, that is our make file, our make.local ready to go. So we can copy our run template to a test directory, and then that should be fine. We should also bear in mind that there are some module dependencies. So you want to load OpenMPI, you'll want to load HDF5 and things like these. I will give a full list of the modules that I load for these runs. Some of them are not necessary for NuPPNP, such as Perl or the zlib, but they are necessary for Mesa, so you'll probably want to put them in your bash anyway. So I'll give you a list of the modules that I have loaded as default. And now let's just check where we are. Yes, that's correct. Oh, I didn't put an R on the copy, so it didn't copy anything. Here we are. Let's go into test. This is our test run test directory, and then let's do make clean. These all seem to be working. Let's make and see if we can get ourselves an executable. Looking good so far. At this point, you could probably go and get yourself a cup of coffee. There we go, and we've made our executable. Now, that's the end of this tutorial, but please bear in mind, if you try to run that executable now, you'll end up with gibberish. It won't work, and that's because there are a lot of parameters that need to be set in, for instance, ppm physics, ppm solver, ppm frames. So don't be surprised if it doesn't work after that. You'll need the next tutorial in order to make sure that you have all of those parameters set correctly. But keeping it short and sweet, that's the end of this one today. Thanks for listening, everyone, and I'll see you next time.